This man has just erected a secret antenna. Well, hello once again, and thank you for joining me on the Waters and Stanton video channel. My name's Peter Waters, and my ham radio call sign is Golf 3 Oscar Juliet Victor. I'm going to talk about secret antennas. What's a secret antenna? Well, a secret antenna is an antenna that is not really visible. You can't see it. The neighbours don't really know it's there. Maybe you've got restrictions. Here in the UK we have restrictions in some areas, and I know that in the USA you have restrictions. You can't put up antennas. But if that antenna is not really visible, then are you breaking any regulations? Well, I'm going to discuss or demonstrate an antenna which I've been experimenting with, an antenna which seems to be working very well. It's a very simple antenna. It doesn't involve much in the way of outlay, and yet I would venture to say that it's not really very visible, and in fact you could call it a pop-up antenna. Why a pop-up antenna? Well, because when you're finished with it you can quickly take it down. There's no sign of any antenna there. There's no visibility that there was ever an antenna there, and yet just as quickly, within a matter of 30 seconds or so, you can erect this antenna and be on the air and work some DX. Yes, I've worked some DX on this antenna. So let me describe to you what I've been doing, and this may give you some ideas on how you can make a secret pop-up antenna. You may not want to copy it exactly, but I think if I show you what I've been doing, it may give you some ideas. Now, the first thing I had to decide is what sort of antenna I was going to erect. I decided a vertical antenna because a vertical antenna doesn't take up much space at all. It's also self-supporting. So a vertical antenna seemed to be the way to go. Now, a vertical antenna, if we're talking about a quarter wave antenna, needs a ground plane, and a lot of people mount the antenna on the ground, but it's been demonstrated time and time again in recent years that the best way to operate a vertical quarter wave is a little bit above ground level, say about a metre or even half a metre. And rather than having loads and loads of radials buried in the ground, you can get away with just one or two. Even one radial works quite well, and it gives you a bit of directivity in the direction of the radial. So I decided that my antenna was going to be a vertical antenna, a little bit above the ground, about half a metre above the ground, and I was going to use a single radial. That doesn't take up much room at all, and it can be very quickly rolled up out of the way. But I can't have a full-size vertical because the neighbours would see it. So I decided to use a short vertical. Let me explain and show you the antenna that formed the basis of my secret pop-up antenna. Now, my idea for this pop-up secret antenna is to use a mobile whip. Why a mobile whip? Well, first of all, they're small. Secondly, they don't cost a lot. They are interchangeable. And the compactness of the idea would seem to be quite suitable for a lot of situations where there's restrictions on antennas. A mobile whip is really not that conspicuous. But how well could you make a mobile whip work in a small garden? Or even a mobile whip work anyway, because obviously there's size to consider. It's much smaller than a full-size antenna. Well, I've done some tests, and as we go through this video I'll tell you what I found. The mobile whip I decided to use was made by a firm called Ampro. They're widely available. We've got a wide range of these in stock, and there's models that cover from 160 metres through to, I think it's 6 metres. I chose to use the 20 metre version simply because it's a band that's open most of the time and there's some good possibilities of DX. As you go lower in frequency, 40 or even 80 meters, obviously the efficiency is going to drop off. So I thought, let's give it a chance. Let's first start on 20 meters. And that's what I've been doing. I've been trying this antenna out on 20 meters. Now let's talk about the Ampro antenna first of all. It's helically wound. It's not base loaded. It's not center loaded. It's helically wound at the lower portion. So it is sort of a base loaded antenna, but that base loading extends for half the total height of the antenna. And the total height of the antenna is just over 2 meters. Helically wound has an advantage. First of all, it tends to be more efficient, and it tends to have a slightly higher radiation resistance, so it matches better to your feeder. And if you bear in mind that the bulk of the radiation from an antenna is at the high current point, and the high current point in a vertical, quarter-wave vertical that is at the point where it's fed. And if you have a lumped inductance there, in other words a base-loaded antenna, you're not going to have great efficiency. It will work, but it won't be as efficient as if you change that to a helical winding. A helical winding is spaced out, and you can see here on the picture of the 20 meter version, and that tends to give better efficiency. Also of interest, I found, and I didn't realise this, that they now make high power models. They make a 600 watt version. So I thought, wait a minute, 600 watt version, that means to say you could actually run an amplifier. Perhaps with an amplifier you can make up for some of the loss in signal strength you get because you're operating quite a compact antenna. So that was my project, to use one of the Ampro 600 watt mobile whips to see how well it works. Now, I guess that the 600 watt version is slightly more efficient than the 100 watt version because the diameter of the base antenna is a bit wide, and therefore you've got a larger coil spacing and a larger coil diameter. But whether that makes much difference, I don't know. But certainly it's more rugged. It looks as if it will take 600 watts. By the way, the 100 watt version I have tried at 200 watts and it's fine. So if you've got one of these 200 watt transceivers, probably the 100 watt antenna will cope. At least it did on 20 meters. But be prudent to get the higher power version because they're not overly expensive. So that's what I use. Now, how about mounting the antenna? Well, I mounted it on a bracket that is readily available, and basically this bracket will mount on a stub mast, and I think the diameter is, I'll put it below this video, the diameter of the stub mast, and you can then see for yourself whether it will fit your particular location. Now, on top of the bracket is a 3/8 inch socket, so you can screw the mobile whip into the socket, and underneath is an SO239 to make your coax connection, 50 ohm coax cable. One thing that I would thoroughly recommend is that where you connect the coax cable to the SO239, you actually make yourself a line isolator, which is a few turns of the coax around a ferrite core, and that will isolate the outer sheathing from having RF currents flowing down it, common mode currents we call, and it makes the whole adjustment of the antenna much easier. Now, one thing I would say is that although we call this a mobile whip, it's not dedicated to mobile work. Yes, it's intended for mobile operation because of the size and so forth, but the same principle of operation applies if you remove it from the car and attach some radials to it. And as we said earlier on, a single radial will work. So although it's a mobile whip, we're not using it for anything other than what it was intended to be used for, a compact, short, vertical radiator. But instead of working against the car body, we're going to make it work against a radial. Now, a bit later in this video, I'll show you a little trick that will improve the matching of this antenna, maybe even get better matching than you would on your car. But we'll come to that a bit later in the video. So in summary, so far, we've mounted our whip on top of a short support mast. It's about half or a metre above the ground, and we've attached a single radial, and that radial should be a quarter wave. So on 20 metres it should be 5 metres. It's prudent to make it perhaps a little bit longer, but we'll come back to that in a minute. First of all, something that I haven't seen mentioned in any of the videos covering the Ampro antennas, and that is that you can get what I call reverse tuning. Let me explain, because I think it's rather important, because you may well run into this yourself when you're experimenting, and you may wonder what the hell is happening. What actually is happening, which really defies logic, is that normally if you shorten a antenna, you expect the frequency to rise, the resonant frequency to rise. But you can get into a situation with the Ampro aerials where shortening it actually lowers the frequency. Let me explain how this happens, so that if you do run into this problem, you won't be scratching your head and thinking, what the hell is happening? Let me show you. This is a diamond antenna, also a 20 metre mobile whip, and you see that the adjustment of the whip is in a section which is a thin tube, and then that thin tube goes down to the loading coil. So to adjust the antenna, or the diamond antenna, you just push it in to make it go higher in frequency, pull it out to make it go lower in frequency. It does what you'd expect. Now, if we take the Ampro antenna, you'll notice that there isn't that tube above the coil. The whip goes straight into the top of the coil, and in order to adjust it, you push the whip in and out. But what actually happens with Ampro antennas is you reach a point where, as you push the actual tuning rod, or the upper part of the antenna, into the base of the antenna to make it go higher in frequency, that stainless steel whip is actually acting as a core. And when you put a core inside a coil, you actually increase the inductance. And what happens with Ampro antennas is that there comes a point fairly quickly where pushing the whip into the antenna actually makes that coil increase in inductance, and so it actually lowers the frequency. Now, there is a little bit of leeway with the Ampro antennas, and if you follow the instructions and set it up as was designed, you won't have that problem. But I just make this point that you can get a point, or can get reach a stage with the Ampro antenna. If you push that whip in more than what the designers expected you to do, then it actually increases the inductance and lowers the frequency. Now, if for any reason you definitely need the antenna whip to be shorter to reach the frequency of operation, which is unlikely, but if you do for any reason, then the way to overcome that is to remove the whip and just cut a centimetre or a couple of centimetres off the whip, and then put it back in, and then you won't have that problem, because you've removed the part of the whip that was acting as a core inside the coil. I make this point because I ran into this point myself actually, and I was expecting it, and it did happen, but I imagine that if you weren't prepared for it, you didn't fully understand what was happening, you might be scratching your head. Anyway, if you use the whip as instructed and you set it up as instructed, you shouldn't really run into that problem. I mounted the antenna on this bracket here, which is dedicated to a mounting bracket for a 3/8 inch mobile antenna. And really and truly, the setup here is as it would be if you had a normal vertical antenna, at ground level. This one is not quite at ground level. I've got about 1.5, nearly 2 foot between that and the ground. It doesn't really matter actually. It's sort of mounted on a metal post here, and this all goes into a concrete base, so there is some sort of earth there. But I've also attached a quarter wave wire here, and This antenna is the 20-metre version, by the way, and I've got a quarter wave radial here, which is 5 metres long, and that seems to work okay. What I am going to do is to try mounting this off the metal post. I'm going to mount it on a fiberglass pole, so that it's totally insulated, so the only earth connection, if you like, will be the radial. But this is the initial setup that I'm going to use, and on initial tests I found that I can quite happily run 200 watts into this without any problem at all, although I have to say I've got a coax run of around about 70 feet, so there's a bit of loss there, so there's not 200 watts going into that. But nevertheless, this is the setup that I'm going to use initially to see how it works. On receive it's quite encouraging actually, but of course that can be different when you're transmitting. So anyway, this is the first setup of this sort of pop-up antenna, because really truly it's very easy just to unscrew this, take it off, put it away, just put a cover over that to keep the water out of the socket, and there we are. No evidence at all of an antenna, so this is my concept, one of the concepts actually, of a pop-up antenna. Now, while I was happy with the performance on receive, I wasn't entirely happy on the transmit side, because I had a VSWR, the best I could get was 1.75 to 1. And I just wondered whether or not mounting it on metal stake in the ground had any effect on the performance, even though I'd put a line isolator on the coax side. So I decided to reinstall the antenna on a fiberglass mast section. That meant to say that the base of the antenna was totally isolated. The only connection to it was the coax cable with the line isolator and the radial to the base of the antenna. And I still had a VSWR 1.75 to 1. That's the best I could get. So it proved to me that the way I'd mounted it in the first place wasn't having any effect on the VSWR. So let me now explain what was happening and how it was cured. Let me show you first of all the setup. I'll explain why I had the problem. We've got a mobile whip there, and we've got a quarter wave radial going there, and we feed it at that point there with coax cable. Now, because of the weather, I didn't get round to measuring the impedance, but I would hazard a guess that the feed impedance there was about 25 ohms. And we are using 50 ohm coax to feed the antenna at that point, so quite clearly there's quite a mismatch. And that probably explains why I was getting a VSWR of 1.75 to 1. Perfectly workable, no problem at all. That was at resonance, but the problem with that VSWR is that if that's the VSWR at resonance, as we go towards the edge of the bands, then it's going to rise quite considerably. And it was rising up to around about 3 to 1 at the band edges. Again, it's workable, despite what a lot of people think. A 3 to 1 VSWR is workable, provided that your transceiver's got an antenna matching unit. Then it will deliver power, and you won't lose more than about 1 to 1.5 dB absolute maximum. So don't get too frightened about VSWR. But let's find out what was happening. And to make it simpler, I'm going to redraw this, and I'm going to show the whip as a horizontal item. And the reason I'm going to show it like that is because I want you to imagine that this actually is a dipole. We've got a long arm there, which is the radial. We've got a short arm there, which is the mobile whip. And we're feeding it at this point there. Now, as I said before, this point is probably around about 25 ohms low impedance, but there's a trick we can do. If we can do two things. If we lengthen that slightly, the mobile whip, in other words, we make it go a bit lower in frequency, and we then shorten the radial a bit. What we do is that we actually move the feed point along slightly. And as we move the feed point along slightly, in other words, away from the centre point, we actually raise the impedance. And it doesn't take too much. Let's, for example, say that we retune this antenna, we make it a bit longer, so that it's resonant at 13.95 megahertz, for example. Megahertz, that is. And we then, in order to counteract the fact that we've gone low, we shorten this radial a bit by perhaps 3 or 4 centimetres. It's trial and error. Shorten it a bit. And if we shorten it a bit, we bring the resonant frequency back to around about 14.2 megahertz. Now, this is cut and try. But what you need to do is you need to either shorten one end and lengthen the other end, or vice versa. Lengthen one end and shorten the other end, only by a smidge. And you adjust this until you see an improvement in the VSWR. And I saw a massive improvement in VSWR. I got an almost 1-to-1 match by doing this. I've gone from 1.75 to 1 at resonance down to almost a perfect match at resonance just by changing these lengths slightly. One length goes longer, one goes shorter. So how does the antenna work? Well, it works extremely well. I was rather surprised. The only comparison I can make was my half-size G5RV, which is up at 28 feet, and that does work pretty well. But I was only getting a drop of 1 S point when I switched to this vertical antenna, and that's quite impressive actually. Occasionally there would be a bigger difference, but also occasionally there would be no difference, which again surprised me. So it looks as if this antenna is a serious contender if you've got a small garden or if you've got restrictions, because it certainly does work. Now, the thing that really surprised me, I'm always a bit cautious when I put up a new antenna, because as I've said on these video channels before, sometimes you can make an assumption before you've actually given the aerial a chance to work. But on the very first day that I installed this antenna and got it going, I was listening on 20 metres. It was around about 6:30 in the evening, I think, and I heard VK2GR. I think it was. I'll check the call sign and put it below this video. VK2GR calling CQ. No reply. So I called him and he came straight back and he gave me 559. Now that wasn't bad. I was running 400 watts, so there is, you've got to bear that in mind. I was running 400 watts and he gave me 559, and I was giving him about 5.6, 5.79. So it was comparable. Turns out he was running a 4-element Yagi, and he was running similar power. But of course, the advantage he had with the Yagi also gave me an advantage, because he was getting the gain on receive as well as transmit. But the following day, I worked another VK Australian station, and this time got 579, again with similar power levels. So it is possible to work some DX with an antenna like this. Now, what I would say is, and I'm sure some of you comment, is yes, you're running high power. Yes, I am running high power. But on receive, the difference is about an S point compared with my horizontal antenna. And even without the amplifier on, and I only put the amplifier on because I was trying to see what decks I could work. With the amplifier off, from just running 100 watts, I have no problems at all in working all around Europe. Now, I haven't had a chance to give it a long-term test. That still remains. But in the 2 weeks that I've been using this antenna, I'm now convinced that if you've got restrictions, this is one way to go. It could be your secret antenna, the antenna that others don't know you've got, apart from the stations you're working, of course. And if it means you can get on the air with restrictions and not offend anybody and not upset anybody, then that's no bad thing, is it? This is on the horizontal antenna, G5RV.
Italy Uniform 5, Tango Radio Oscar, you 589. 59, and the TBT in Italy, okay? Many thanks. Thank you, 44, good luck, you are set.
I've now switched over to the mobile whip.
For India Yankee Whiskey, hello, you 589. 509, 73. Thank you, au revoir, Delta Papa 44, Whiskey Charlie Alpha, you are set.
A Golf 3 Oscar Juliet Victor.
Golf 3 Oscar Juliet Victor, hello, you 589 plus, over.
Yeah, okay, you're also 59 plus from Golf 3 Oscar Juliet Victor.
Thank you, 7344.
Now, it should be possible to actually multiband this. You could actually, I think I'm not an engineer, but you could probably engineer something so you could have 2 or 3 whips in parallel mounted together. You'd have to have separate radials, but you can run radials in parallel, so that's not too much of a problem. Anyway, I hope that gives you some ideas. I hope it gives you some confidence that even in quite severe restrictions, you can work DX. And yes, hand up, I did run high power on occasions, but that was just to prove that it worked. But equally well, it worked with 100 watts. And as I say, I was getting, generally speaking, no more than 1 S point down on a much larger antenna. Okay, well, thank you for watching this video. Thank you for support. Don't forget to press the subscribe button. That helps us, and it helps you because you'll be notified when another video comes up. In the meantime, you enjoy ham radio. Take care, and don't forget, Waters and Stanton, we send gear all over the world. We've got some great prices, great second-hand deals. Give us a call, whatever, and we'll be happy to help you out. Thanks for watching. Take care. Look forward to seeing you in the next video. Bye for now.